Okay, 47. If z is the standard normal random variable, find the probability that z is greater than or equal to 0.6. Okay, so now there's two ways these normal distribution questions can be asked. Normal random variable questions can be asked. One is when we're already given our z value and we're asked to find a probability involving this z value. If you're given a probability involving this z value, so if you're given the z value, use the table immediately. Now remember, the table gives the probability that z is less than or equal to your z value. The table always gives you less than. If you want the probability that z is less than your value, use that number from the table and you're good to go. If you need the probability that z is greater, let me write that z, capital Z. If you need the probability that z is greater than or equal to your z value, use 1 minus the probability that the table gives you. And I'll show all of this, what I mean, in a second. 1 minus the probability that z is less than your value. So this problem asks for the probability that z is greater than or equal to 0.6. And that's equal to 1 minus the probability that z is less than or equal to 0.6, which is what the table gives us. The reason why we use less than is because that's what the table gives. So first we're looking for the probability that z is less than or equal to 0.6. I'm going to go down to my table here. And as you can see, the table gives us the area to the left. It gives us the probability that z is less than our value. The table always gives you less than. No matter if you're looking at negative z values or positive z values, it still gives you less than to the left. So we're looking for z is less than 0.6. So I'm looking in the left column, the z column here, 0.6. If I want a 0.60, that's here. Oh, sorry, here, 0.61, 0.62, 0.63, 0.64, 0.65, 66, 7, 8, 9, etc. So I want 0.60, which is right here, 0.6. That's 0.7257. This is 0.7257. What that's saying is, this is my normal distribution. Let's use my drawing. It's terrible. Here's my mean, which is 0. And here, let's say, is 0.6. The probability that our value is less than 0.6 is here, is all of this to the left. That probability, that area, the area under the curve here to the left of 0.6 is 0.7257. But this problem is asking for this area here. This problem is asking for the area in the red. This problem wants the area to the right, the probability that z is greater than 0.6. So since the area under the entire curve is 1, I'll just subtract 0.7257 from 1, and that'll give me the probability that z is greater than or equal to 6/10. So 1 minus 0.7257 is 0.2743. Right, 2743. Yep. So the probability that z is greater than 0.6 is 0.2743. And that's how we would do this.